Hello everyone, myself Ritika Tyagi. Today we are going to discuss class 10th chapter electricity, numericals based on resistance and resistivity, 7 important numericals which we are going to discuss covering the NCERT questions. Let's start. Numerical number first. A wire of 10 meter long, 0.2 mm in diameter has resistance of 10 ohms. Calculate resistivity of its material. Given is the length of wire 1 meter, diameter of wire 0.2 mm. First convert diameter into radius, that is R equal D by 2. Now 0.2 divided by 2, then we get 0.1 mm radius. Convert millimeter into meter. 1 millimeter is equals to 10 to the power negative 3 meter. It is the relation between 1 millimeter and meter. Then R equal 0.1 multiplied 10 to the power negative 3 meter. After that, displace the decimal. We get R equal 10 to the power negative 3 by 10. Power of this 10 is 1. Now carry it to the numerator. We get 10 to the power negative 3 and negative 1. Sign change from denominator to numerator. Then it is 10 to the power negative 4 meter. It is the radius of the given wire. Area of wire is equals to pi r square. Value of pi is 3.14 multiplying 10 to the power negative 4 ka square. Length is given 1 meter. Area we get. After that, resistance. Resistance of the wire is 10 ohms. Resistance of the wire is 10 ohms. Then applying the formula to calculate resistivity. As we know, rho equal Ra by L. Then value of R is 10. Value of A is 3.14 multiplying 10 to the power negative 4 square. Value of L is 1. Then here we get 3.14 multiplying 10 to the power negative 8 and positive 1. Then it is 3.14 multiplying 10 to the power negative 7. On displacing the decimal by 1 digit, we get 31.4 multiplying 10 to the power negative 8 omega meter resistivity of this wire. Value for L is given 1 meter, resistance 10 ohms, diameter 0.2 mm. First convert diameter into radius, that is diameter by 2, 0.1 mm radius. Then convert millimeter into meter by multiplying 10 to the power negative 3. After that, put the value for area, that is pi r square. Now applying the formula for resistivity Ra by L, putting the value for Ra and L, and on calculating we get 31.4 multiplying 10 to the power negative 8 omega meter resistivity. Now numerical number second. What will be the resistance of a metal wire, length 2 meter, area of cross section 1.55 multiplied 10 to the power negative 6 meter square if the resistivity of the metal be 2.8 multiplying 10 to the power negative 8 ohm. Here given length 2 meter, area of cross section 1.55 multiplying 10 to the power negative 6 meter square. Value for resistivity 2.8 multiplying 10 to the power negative 8 omega meter. Then we have to find the value for R. Applying the formula R equal rho L by A. Then we get rho 2.8 multiplying 10 to the power negative 8. Value of L is 2. A is 1.55 multiplying 10 to the power negative 6. Cancel the decimal, putting the 0. We get R equal 280 multiplying 2 10 to the power negative 8. On taking the power of 10 from denominator to numerator, that is positive 6, divided by 155. Then 560 divided by 155 multiplying 10 to the power negative 2. On cancel it by 5, we get 112 by 31 multiplying 10 to the power negative 2. Dividing 112 by 31, we get 3.61 multiplying 10 to the power negative 2 omega resistance. We can also write it as 10 to the power negative 2 means divided by 100. Then we get 0.6 omega resistance of this wire. Here L is given 2 meter, area of cross section and the resistivity. We have to find the value for R. Then R equal rho L by A, putting the value for L and A. Then we calculate 10 to the power negative 2. Negative 2 means in denominator it is 100. Then dividing it by 100, we get 0.036 omega resistance. Solving numerical number 3. Calculate resistance of a copper wire 1 km long, 0.50 mm diameter if resistivity of copper wire is 1.7 multiplying 10 to the power negative 8 omega meter. Here we have to find the value of R. Length is given 1 km. Convert 1 km into meter, that is 1000 meter. Now diameter is given 0.50 mm. Convert it into radius, that is d by 2. 0.50 divided by 2, we get 0.25 mm. Now convert millimeter into meter by multiplying it 10 to the power negative 3, because 1 millimeter equals to 10 to the power negative 3 meter. Relation between 1 millimeter and meter. Now A equal pi r square. Putting the value for pi 3.14. R is 0.25 multiplying 10 to the power negative 3 ka square. On solving it, we get 0.19625 multiplying 10 to the power negative 6 meter square. That is the area of this wire. Value for resistivity is 1.7 multiplying 10 to the power negative 8 omega meter. Formula for calculating resistance, that is R equal rho L by A. Putting the value for it, we get 1.7 multiplying 10 to the power negative 8 multiplying 1000 and divide it by 0.19625 multiplying 10 to the power negative 6 meter square of area. On solving it, we get 8.66 multiplying 10 to the power negative 8, positive 3, these 3 zeros, and positive 6. Then it is 8.66 multiplying 10 to the power positive 9 and negative 8, that is 1. It is equals to 86.60 omega resistance of this wire. Here we have to find the value for R. Length is 1 kilometer. Convert into meter, 1000 meter. Diameter is given 0.50 mm. Convert first into radius by taking its half, that is 0.25 mm. Then convert it into meter by multiplying 10 to the power negative 3. After finding the value for A, pi r square, area of cross section of wire. Putting the value for it and calculate it. Then applying the formula for calculating R, that is R equal rho L by A. Putting the value for it, on calculating it, we get 86.60 omega resistance of this copper wire. Solving numerical number 4. Calculate resistance of aluminium cable of length 10 km, diameter 2.0 mm if resistivity of aluminium is 2.7 multiplying 10 to the power negative 8 omega meter. L is given 10 km. convert kilometer into meter by multiplying 1000. That is 10 to the power 4 meter is the length of this aluminium, and diameter is given 2.0 mm. Finding the radius, dividing diameter by 2, we get 2.0 divided by 2, that is 1.0 mm. Now convert 1 mm into meter, we get 10 to the power negative 3 meter. As it is 1, then we can also write 1 multiply 10 to the power negative 3 meter. Resistivity is given. Value of A is pi r square. Value of pi is 3.14 multiplying 10 to the power negative 3 ka square. So here 3.14 into 10 to the power negative 6 meter square is the area of cross section. Formula for resistance, that is rho L by A. Putting the value for rho 2.7 multiplying 10 to the power negative 8. Length is 10 to the power 4. Area of cross section is 3.14 multiplying 10 to the power negative 6. 0.8598 multiplying 10 to the power negative 4 and this positive 6. Then it is on displacing the decimal, we get 85.98 multiplying 10 to the power 2 and negative 2 by displacing the decimal by 2 digit. Then we get R equal 85.98 or approx 86 omega. Here length is given 10 kilometer. First convert kilometer into meter by multiplying 1000. That is 10 to the power 4 because there are 4 zeros. Next diameter is given 2.0 mm. Convert into radius, we get 1 mm. Convert 1 millimeter into meter by multiplying 10 to the power negative 3. Then radius is 10 to the power negative 3. And A, that is pi r square. Value of pi and r putting together, we get 3.14 multiplying 10 to the power negative 6 meter square area of cross section. Applying formula for finding resistance, that is rho L by A. Putting the value on solving it, we get 86 omega resistance. Here 10 to the power negative 8 and positive 4, that is negative 4 and negative 4, negative 6 numerator में जाके positive 6, that is positive 2. Displacing the decimal by 2 digit, we get negative 2. Positive 2 and negative 2 cancel each other, that is 10 to the power 0, which 10 to the power 0 and it is equals to 1, that is 85.98 or approx 86 omega. Solving numerical number 5. Calculate the area of cross section of a wire if its length is 1 meter, resistance is 23 omega, resistivity of the material of the wire is 1.84 multiplying 10 to the power negative 6 omega meter. Here as we know R equal rho L by A, then A equal rho L by R. Putting the value for rho, then it is the formula for finding the value of A. Now putting the value for rho, 1.84 multiplying 10 to the power negative 6, length is 1 meter, resistance is 23. On calculating it, we get On calculating it, we get 0.08 multiplying 10 to the power negative 6. Here, displacing the decimal, that is 8.0, is equals to 10 to the power negative 6 and 10 to negative 2. Because we displace the decimal by 2 digits, that is negative 2. Then it is 8 multiplying 10 to the power negative 8 meter square is the area of cross section of the given wire. R equal rho L by A, then A equal rho L by R. Putting the value for rho 1.84 multiplying 10 to the power negative 6, L is 1, the R is 23. On dividing 1.84 by 23, we get 0.08 and then 10 to the power negative 6. Displacing the decimal by 2 digit, it is 8 multiplying 10 to the power negative 8 meter square. Let us solving numerical number 6. Resistance of a metal wire of length 1 meter is 26 ohms at 20 degrees Celsius. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal at the temperature? Given is the length of wire 1 meter. Resistance is 26 ohms and the diameter is given 0.3 mm. First convert it into radius, that is 0.3 divided by 2, we get 0.15 mm. Now convert into meter, we get 0.15 multiplying 10 to the power negative 3 meter, because 1 millimeter is equals to 10 to the power negative 3 meter. Now area of cross section is equals to pi r square. Putting the value for pi 3.14 and r 0.15 multiplying 10 to the power negative 3 whole square. On solving it, we get 0.0706 something into 10 to the power negative 6 meter square area, which is approx equals to 0.071 multiplying 10 to the power negative 6 meter square. Now we have to find the value of resistivity, that is rho equal Ra by L. Putting the value for R 26, area of cross section 0.071 multiplying 10 to the power 6 divided by length, that is 1. On solving it, we get 0.846 multiplying 10 to the power, that is negative 6 omega meter. Solving numerical number 7. A copper wire has a diameter 0.5 mm, resistivity 1.6 multiplied 10 to the power negative 8 omega meter. What will be the length of this wire to make its resistance 10 omega? In part, how much does the resistance change if the diameter is doubled? We have to solve part A. We have to find the value of L. Diameter is given 0.5 mm. Then radius is equals to diameter by 2, that is 0.5 divided by 2, we get 0.25 mm. Now converting it into meter, that is 0.25 multiplying 10 to the power negative 3 meter. It is the radius of this wire. Then A equal pi r square. Putting the value for pi 3.14, r is 0.25 multiplying 10 to the power negative 3 ka square. On solving it, we get 0.19625 multiplying 10 to the power negative 6 meter square. It is the area of cross section for the given wire. Now that is rho L by A. We have to finding the value of L, Ra by rho. Now putting the value for R, which is 10, A is 0.19625 multiplying 10 to the power negative 6 divided by rho. Rho is 1.6 multiplying 10 to the power negative 8. On solving it, we get 0.12262265 multiplying 10 to the power negative 6, positive 1 and negative 8 is positive 8. So on calculating it, we get 0.1226 multiplying 10 to the power positive 9 and negative 6, that is positive 3. On displace the decimal by one digit, we get 1.226 multiplying 10 to the power 2 meter length of this wire, or we can say 122.6 meter length of this wire. 122.6 meter by multiplying 10 to the power 3 or displacing the decimal by 3. Solving part B of this numerical. How much does the resistance change if the diameter is doubled? As we know, R equal rho L by A, then R equal rho L by pi R square. That is the area of cross section of the wire. Now rho L by pi R equal D by 2, that is D square by 4. It is now equals to 4 rho L by pi D square, equation first. Now it is given that diameter is doubled. Then new resistance let R dash is equals to rho L by A. It is given that diameter is doubled. Then it is equals to rho L by 2D by 2D by 2 whole square. That is R dash is equals to 2 cancel 2, that is rho L by D square. Now it is the second equation. Dividing equation second by first, we get R dash upon R rho L by pi D square, dividing by value of R, that is 4 rho L by pi D square. Here D square cancel D square, rho L cancel rho L, that is 1 by 4. Then R dash is equals to 1 by 4. R dash by R ratio is equals to 1 by 4, that is R dash is equals to R by 4.